So here's one of our challenging tree diagram questions. Reading the information, we can see that there are 2 white counters and there are 8 blue counters. So in total, there are 10 counters. So we know that the probability of getting a white and the probability of getting a blue will be out of 10. For a white, we know that it's 2 out of 10, and for a blue, we know that it's 8 out of 10. And by all means, we can cancel them down if we wanted to. It's not essential though at this stage. Reading on, and you've got to read the questions carefully, we can see that one counter is drawn at random, but then it is replaced, which means that the probabilities do not alter. If it wasn't replaced, there would no longer be 10 counters, there would be 9 counters, and that would alter all of these. However, it's replaced, so they are not altered. That stays as a 2, that stays as an 8, white is 2, blue is 8. So there's your tree diagram completed. Work out the probability that both the counters are blue. So blue and blue, that is the one that we're after. Blue is 8 out of 10, and so times blue is 8 out of 10, and you multiply them together and you get 64 over 100. 8 times 8 is 64, 10 times 10 is 100, and that you can cancel down, which is 16 over 25. I've done it quickly, but it could be done by cancelling down by 2 to start off with, and then cancelling down by 2 again, or it can be cancelled down by 4 straight away. So here's another tree diagram question, but this time we are looking at the probabilities written as decimals. We're told the probability that Emma passed her science test is 0.6. So that means the probability that she fails is 0.4, because as I said in the previous lesson, total probability must add up to 1. 0.6 and 0.4 does add up to 1. Technology, the probability that she passes a technology test is 0.3. So the probability that she fails that is 0.7. Now with the technology test, we have that written twice, because from a science test point of view, if we pass it, then technology is pass or fail. If we fail it, technology test is pass or fail. You have to have a branch off each outcome. So arguably, this is just a repeat of the 2 branches above. So there's your complete tree diagram. What is the probability that Emma passes only one of these tests? Now this is a bit more challenging than the last example, because there's more than one option. She could have passed a science test, but then failed her technology test. That's passing one of them. Alternatively, she could have failed the science test, but then passed the technology test. So that's the other outcome. Let's take each one separately. So science test passing is 0.6, and so times failing the technology 0.7. We've got 6 times the 7, we've got 42, but we've got 2 decimals in, so we've got 0.42. And all probabilities, if they're in decimal form, have to be as 0 anyway, because the highest it can be is 1. Let's do the other one though. So you could fail the science, which is 0.4, and so times pass the technology, which is 0.3. 4 times 3 is 12. Again, 2 decimal points in, so 0.12. So the answer to this question, the probability that she passes only one, is that outcome, or that outcome, which gives us a total of 0.54. So she just got over half a chance of passing one of the tests. Okay, another one with decimals. Here we've got 2 people running different races. We're told that Isaac's probability of winning is 0.1, so that means that the probability that he doesn't win is 0.9, total probability being 1. Elizabeth, on the other hand, the probability that she wins a race is 0.3. So the probability that she doesn't win is 0.7. And as with previous ones, because Isaac could win and then Elizabeth could win or lose, or Isaac could not win, but Elizabeth could win or lose, Elizabeth's branches need to be written twice for that reason, as you just followed. 0.3 and 0.7, just repeating the two branches above. What's the probability that neither win the race? Well, that means that Isaac loses the race and Elizabeth loses the race, so that is that outcome. Whereas, for example, that outcome there is just Elizabeth loses, Isaac won. And likewise, that one there is that Isaac lost the race, but Elizabeth won. This is the one where neither win the race. So that is 0.9 and 0.7. Well, 9 times 7 is 63. 2 decimal places in, so 0.63. That's the only outcome we were looking at, so there's our answer. So we've got a game consisting of a fair spinner. That means in this spinner, three-sided spinner I should say, we've only got 3 options. So it's a probability out of 3. And because that spinner doesn't alter, every single outcome will be out of 3. The spinner has the numbers 1, 2, 3 on the sides, and probability of getting a 2, there's only one chance of getting a 2, so there's 2 chances of not getting a 2, and that, as I've already said, does not alter for any of these outcomes. So it's an easier one to fill in. What is the probability that only one spinner lands on a 2? Only one. So if I get a 2 with the first spinner, I don't want to get a 2 with the second spinner, so that outcome. However, if I don't get a 2 on the first spin, I could get a 2 on the second spin, and that's getting 1, 2. So again, we've got 2 options to look at. Now the first one, that top one, was 1/3 and 2/3. So 1/3 and, so times 2/3, which works out to be 1 times 2 is 2, 3 times 3 is 9. This bottom one was 2/3 and 1/3, so effectively just the other way around, and it leads to the same result, 2/9. So because there's 2 options, the probability that we get one spinner landing on a 2 is 2/9 and another 2/9, so the answer is 4 chances out of 9.